is that we're going to take things that are called conditional statements. Believe it or not, and I learned this from second hour, which surprisingly I learned something. Joe, you know, you'd understand. Anyway, I kid. You guys have actually been using conditional statements for a long time. If it's seventh hour, then you're in geometry, right? Things like that. If it's Tuesday, then you are at school. Is that true or false? What's that? Not if you're sick. So would that be a true or false statement? It's a false statement because you can have what's called a counterexample. We'll define all that in a little bit. So you were just saying the conditional statement was a what? Hypothesis and a conclusion. You're right. You probably saw that in science, right? Yeah. Yeah. From what I've heard, that this is pretty common in science classes. This is where they kind of start to teach you guys a little bit on that info. Hypothesis testing is an if-then. Or I would say testing, but it's not a hypothesis statement. Goes to your if-thens. This is the if-then. Okay? If it is Tuesday, then you were at school. Remember, they don't always have to necessarily be true. One of the other things that you will see with these is that we're going to start labeling these things out a little bit differently as well here in a second. So we have this conditional. Now, most textbooks and things, well, actually, let me rephrase this. You guys ever heard the term mind your P's and Q's? All right. Mind your P's and Q's is when I'm trying to tell you to behave. Watch what you're saying. Watch what you're doing. This is why. It's an argument. If then, P implies Q. It came from watch your statements. Conditional statements, if, then. Hypothesis, conclusion. P implies Q. That's where this comes from. Okay? P implies Q. Two angles are supplementary if they are a linear pair. Ooh, let me try that. Yeah, I'm going to blow this up a little so you can see it, and then I'm going to put it to the if then of it. Oops. This is a generic statement. Two angles are supplementary if they are a linear pair. There's no if, there's no then. We're going to turn that into a statement. Two angles are supplementary if they're a linear pair. Now, what I want to look at here is I want to take that boring, annoying sentence and turn it into an if-then statement. The reason why we switch it to this if-then statement is because we can manipulate the words on it to show how things work. Okay. Now, first off, two angles are supplementary if they are a linear pair. Is that a true or a false statement? Okay, we have some trues, we have some false. All right, we'll come back to that in a second. How would you say that in terms of if and then? It's quite literally putting the words if and then in there. You flip things around. Take the exact wordage. Take the exact words. What do you got? Yeah.
Oh, if
Perfect. You are quite literally taking the words and putting an if and a then in the statement. Why? Oh, they said why. Like, there's no why in it. It's just if and then. If two angles are supplementary, then they are a linear pair. It is quite literally putting that information together. Okay? That's what you call a conditional statement. If two angles, are supplementary, then they are a linear pair. If then. Hypothesis, if they're supplementary, linear pair. All right. Hypothesis, supplementary. Conclusion, linear pair. Now let's get back to this idea if that's a true or a false statement. I had a couple people say true, and a couple people said false. Well, let's think about what that means. Supplementary angles are what? Okay. Linear pair are what? They're also 180, but they're more specific, aren't they? Exactly. Linear pair, they form the line, don't they? Yeah. Supplementary angles just have to add up to equal 180. Do they have to necessarily be on the same line? No. They don't. Remember, you could actually have a 30-degree angle here and a 120-degree angle here, and they're still supplementary. They're just non-adjacent. And that was okay. Linear pair was just a more specific version of that. Does that make sense? Now, that's the idea of what happens here. We get to use what are called counterexamples. You ever heard of that before? Look on your faces, that's a big fact. No. A counterexample is not an example of a countertop. It is not a person that counts, for example. Counterexample. Anything that disproves something. Diagram, statement, whatever. Anything that disproves something. Doesn't matter what it is. We use statements. We use diagrams. We use definitions. We need anything. So for the example we just did, where we talked about if two angles are supplementary, then they are a linear pair. Well, that's a conditional statement, but it is a false statement because you could have 30 degrees here and 120 degrees here. Those are supplementary, but they're not a linear pair. Does that make sense? What's that? This statement? Yes. It's still, you still wrote it out correctly. Bless you. You still wrote it out correctly, but it wound up being a false statement. Okay? It's weird how this stuff works. These are all going to be arguments. Okay? Remember, you're teenagers, you like to argue. I know, I was one. Teach a lot of them, things like that. Bless you. This is how you create the valid arguments. All right? This is how this stuff goes through. Another really, really easy example, and you don't have to write this out, but if you just think about it. If you are a teenager, then you are 15. True or false? Why? You could be 13, you could be 14, you could be anything else besides 15. Okay? Exactly. Those would be considered counterexamples to a statement. That's quite literally all this stuff is. Right? Not bad? All right. So we go, like I said, I use this idea of P's and Q's. That's your if, then. Excuse me. When you use and you see these P's and Q's, if you understand the way that the lettering of P's and Q's work, because we're not 4 of these setups, all it is just rewording statements, putting them in a different order. Okay? It's math for the, like, unmath. Makes any sense. There's like no numbers in this. Just logic for the first few days. Okay? Usually what happens with this first few sections, in the newer textbook, it's mainly sections 2.2 and 2.3. There's a little bit of 2.1 that we mix in throughout it. It's kind of what we're doing today and tomorrow. Then after that, I think I showed you guys what we're getting towards, right? How we're going to eventually get to the idea of a proof.
Yeah.
Where what we'll do, probably starting next week, is start talking about definitions and properties of how you prove algebra. You guys all know how to solve a two-step equation. What we're going to do is list the reasons why you're doing things. This idea of the logic will help us slow our brains down in such a way that we'll be able to list things in a chronological order. That's kind of all this is. Okay? So with that said, I'm looking at having a rather short quiz come Friday. I don't anticipate it being more than, on the page, maybe a half dozen problems, 10 problems, something like that. But it's a little bit more writing. That's why I wanted to give it the time so you guys can write, because please write legibly. Please, when it comes to these things, okay? So anyway, this is where we're headed. It's a lot of words today for the next couple. If this had been an actual emergency, the signal would have been followed by official information. What's the hypothesis? That it's not, or is? Okay. If this had, the hypothesis was, if it had been, not if it isn't in there. The hypothesis is if it had been an actual emergency. What you're doing is what we'll talk, and now remember what you said there. I'm going to show you what you're doing here. You're flip-flopping these, and you still have a valid statement. And I'll explain that in a little bit. What you did is the inverse. Okay? Well, and it's okay. He's just, 10 minutes ahead of us right now. What's the hypothesis here? If it was an emergency, what's the conclusion?
It's not.
The what? What about it? I can't hear you anymore. Exactly. It is quite literally take the first part, hypothesis, take the second part, conclusion. There's no guesswork here. There's no making things up. Okay? Hypothesis, if it was an emergency, conclusion. Official information would have followed. Okay? That's really all this is. There's no real ambiguity to this. So, if an emergency official it was an emergency, official information will follow. Okay. Hypothesis, conclusion, P, Q. Okay? Okay? Okay. Let's take a generic statement and let's write it as an if then. The generic statement here states perpendicular lines. What I want to do is turn that into a conditional statement. What I mean by a conditional statement, I want to put the words if and then in it. What do you say? Yeah. You flipped it. What's first? Yeah. And what's happening here is you take what they start with. What are you starting with? Well, if you have perpendicular lines, then they intersect. What you were saying is you're flipping. You're saying if they're intersecting, they're perpendicular lines. When you get to these things, you're writing them out in terms of if-then. Start with them as exactly the way that you see it. Throw the word if in front of it. And sometimes you have to say if they, or if two lines, or something like that. But for the most part, it is if two lines are perpendicular. You guys have all seen that symbol, right? Upside down T. You should have learned that in algebra. That's how we show things are perpendicular. Well, that's what that means. Okay? That symbol stands for perpendicular. I will use that all the time. Do you remember what this symbol stands for?
Parallel.
Okay, came at the same time, same unit. So if two lines are perpendicular, then they intersect. What's your hypothesis? And what's the conclusion? Okay, is that true or false? True. By definition, perpendicular lines intersect and they create what? What's that? They create 90-degree angles. Okay. So this is a P implies Q, and it is a true statement. Okay. If two lines are perpendicular, the conclusion is they intersect. So conditional. If two lines are perpendicular, then they intersect. And you guys just told me that's true. Okay? Say it backwards. Flip them. So what I mean is, let's say your conclusion first and then do your hypothesis. If two lines intersect, then they are perpendicular. Did I hear that all right? So if we flip them, it's called the converse. The converse is taking the conclusion implies a hypothesis. That's why we start with the if P then Q, and now it's Q and P. We're just flipping the statement, okay? So we have conditional. If two lines are perpendicular, and we said that that was true. Converse is saying it backwards. If two lines intersect, then they are perpendicular. What's that? True or false? If two lines intersect, then they are perpendicular. True or false? False, isn't it? It has to be false. Because what? Not necessarily. We got steps. What's that? Give me an example. Show me. Use your arms. It's like that? Yeah. Is this a decent enough counterexample? We can use counterexample. What you said wasn't wrong either, because they don't have to be perpendicular. Two lines can intersect and they can create an angle that's 100 degrees. They can create an angle that's 170 degrees. All right? It doesn't necessarily have to be 90. Two angles or two lines can wind up being the same line. Okay? And they intersect infinitely if they have to. It's one of those things that this statement isn't necessarily true. So we say that that is a false statement And then our counterexample would be, but that's 100 degrees. And that's fine. A lot of times, diagrams or another worded statement is perfectly legitimate for a counterexample. It's anything that disproves your statement. Okay? And I know you were just finishing up your geometry. Oh, guys, I'm sorry. I'm awful. This is Mr. Ibernito. I pronounced that right? Yes. He's going to be with us for about, I don't know, a couple months maybe or so. As the glorious job of learning to become a teacher, you get to do what are called observational hours. In your observational hours, not only before you get loaded up to get ready for doing your student teaching, which you have to pay to go do, a job that you don't get paid at, you have to spend X amount of hours with students and people like that to weed out the fact that you see if you really want to do this, for the lack of better terms. So he'll be with you got like 30 some odd hours or something like that. So he'll be here Tuesdays, Thursdays, and I know you're doing start tutoring as well. Yes. So you already have your math degree, so he's already kind of SMRT. Good luck, Collector. Good luck. So I know he'll be around for that. He'll be in here helping out with flexes and all those couple of days as well. So, but eventually we'll put him up front. You guys can get a lot of those teaching. All right. So then, and I know you guys do. You basically do the same thing in axiomatic geometry. That's kind of how that stuff starts out, where they give you all these different definitions. You know, if two angles are supplementary, then they add up 180. All those things build themselves out where you're going to be using this, and you can still do the truth tables of P's and Q's. That's where it comes from. All right? So counter says Q implies P. If two lines intersect, then they are perpendicular. And like we just said, that is a false statement because you can say that they've intersected 100 degrees. Okay? There are two others. The next one is called the inverse. The inverse of a statement is not P implies not Q. That little symbol there, I think, do the axiomatic ones still use that symbol, or do they use tilde? Use tilde? I just noticed our new book uses tilde. I grew up learning it like this. Okay. What this symbol means, guys, that means not. P implies not Q. I just found this out today also. Well, our old textbook used that symbol. Our new textbook uses tilde. You guys know what tilde looks like? All right, tilde is just single squiggly. Oh. All right, single squiggly, it means the same thing. Not P implies not Q. So if you see it written either way, that's what it means. Okay? I'm old, and I learned it with the not symbol like that. So what you're doing here is you are negating a statement. In order to negate a statement, all you have to do is put the word no or some form of the word no in it. This is not a pencil. I just negated it. All right? It's quite literally all it means, okay? So if I go back to the inverse, if two lines are perpendicular, then they intersect. To negate that, I would say if two lines are not perpendicular, then they don't intersect. It's just putting the word no in it. If two lines are not perpendicular, then they do not intersect. two lines are not perpendicular, then they do not intersect. All right? True or false? Two lines are not perpendicular, then they do not intersect. False? Give me a counterexample. What's that? So two lines do not, two lines are not, are not perpendicular. And you can use the exact same example. It's false. If two lines are not perpendicular, that just means they don't measure 90, they don't intersect. Well, here there's two lines that are intersect, and they measure at 100 degrees. They still intersect. Okay? A lot of times with counterexamples, you don't have to come up with a new one a lot of times. They work themselves out that they fit multiple scenarios. Especially as you get into the converse and inverse stuff. Or the first statement's true. There's tricks to this. Okay? So conditional, P implies Q. Two lines are perpendicular, then they intersect. Converse, say it backwards. The two lines intersect, then they are perpendicular. In this case, that's false. For example. Inverse, throw the word not in there. So we have not P implies not Q. Two lines are not perpendicular, then they don't intersect. And then the last one, if you look at the way the lettering has gone, P to Q, Q to P, not Q, what do you guess might be the next one?
Not true.
Very good. Not Q, not P. That stands for contrapositive. Exactly. Not Q implies not P. It's called the contrapositive. You say it backwards and you put the word no in it. If two lines don't intersect, then they are not perpendicular. Okay? What happens here is you have your original, not the original, backwards, and the backwards not. Okay? Stop it, you two. Write stuff down. Okay? That's enough. I get it. That's enough. Both of you guys probably need to pay attention. Excuse me. If two lines are not, sorry, I said that. Two lines. I just did that one. Two lines do not intersect, then they are not perpendicular. Is that true or false? It's true. Because if two lines don't intersect, what will they be? Parallel. Will parallel lines ever be perpendicular to each other? No. All right. This case is a true statement. So it's false. Put it on here. Okay. A lot of times with these, whenever we're doing these, we always say whether or not they're going to be true or false. And if they are false, we always give what we call a counter-example. Right? The counter-example is anything that disproves it. I'm going to run out of space here. So, contrapositive. Is not Q and not P. Okay? Here is a conditional. Oh, wait, I have one on here. take a minute. There's a conditional. If it is raining, then it is cloudy. P implies Q. Go through all of those. Do the statements true or false. If they're false, show a counterexample. And run through them. Take a few minutes and see how we do. Yeah. Go through all. I gave you the first one. The first one is the P implies Q. I didn't tell you whether it's true or false. Okay. But that's your first one is the P implies Q. All right. Give that a second. A little short here. Now, I got in the argument second hour with this first one about if it is raining, then it is cloudy. Is that true or false? It could be. And it's true-ish. Okay. I looked at it this way. It could be raining out, but yet the sun's coming out over the side. You know what I mean? So, but here's. I know, but other people argued that too, and I know it's kind of a crafty example, so it's one of those things, okay? So as long as you stay consistent with how you go, I try to make these as straightforward as possible, so you don't have to worry about the vagueness of it. So this is kind of. So if I go through this, we'll just say it's true. Go away. We'll just say it's true, okay? Converse. Say it backwards. Right. If it's cloudy, true or false?
False.
False. Why? Because it was cloudy yesterday. Right. And that's it. Yeah.
Oh.
It's cloudy now. I mean, we can see it's cloudy. I can see clouds, but it's not raining. Okay? And that's what you're looking at. Can you come up with some way of showing that you can disprove it? Inverse. Well, the inverse says if it's not raining, then it is not cloudy. True or false? False, because it's cloudy right now. Okay? You can. A lot of times you can. You don't have to come up with a new one, and that's what's nice about a counterexample. A counterexample is anything that disproves it. So if it's not raining out right now, it's cloudy. There you go. There's your counterexample. And then lastly, if I throw in there the contrapositive. If it is not cloudy, then it is not raining. True or false? True. I know, and that's weird. It's weird to think of it like that, and that's what it is. This is mathing without math. It's really what this is. If it is bless you. What's that? It's very similar. There will be little bits and pieces like identify the hypothesis, the conclusion. Is it a valid statement? Can you rewrite these four things out? Give a counterexample. There's no like 2x plus 5y is 7. Well, that's a system equation. You have to have two equations. But anyway, there's none of that kind of stuff. Okay. And today what we're doing is a lot of this. And this could take us a few days to get through a bunch of the materials. Yes, sir. What? We will, but not until next week. We're not going to worry about, but we'll only have one variable, but we're going to get into solving an equation, but we're going to have to list the reasons and steps as to why we did it, because for every statement, there has to be a reason. What's the rationale behind what you are doing? This stuff allows you to start to think about, all right, what is the string of events that I have to make it a valid argument? And that's how we build it. Okay? I think I already posted it on the calendar. I think somebody counted, it's only like 13, but it's a lot of them are, what are a couple of parts of things? I think there's only like 3 or 4 when you actually have to write out all 4 parts. I can't imagine it's going to take very long to go through. This is in the new book, so you have to use the link from the Pearson to get through it. Just so you guys know, I don't have this stuff PDF'd. I wish I did, but I can't. I could, but it would be illegal. And true, but in my heart of hearts, that's stealing. Stealing from the conglomerate of Pearson. You know, they are the ones that, you know, they're right, they make the math. What's that? They're not stupid. It's one of those things that multinational conglomerates take over everything. Okay? It's kind of how it works. It's like Toys R Us filed for bankruptcy today because you guys don't play with toys. You'd rather play with your video game and your iPad and your phone and then sit there and go play G.I. Joes and Hot Wheels. Think of all the kids that aren't going to have toys when they grow. Your kids won't be able to go to Toys R Us. You know that? Because you guys never went to Toys R Us. Have I made you feel guilty at all yet? Hey, I love my G.I. Joes, man. We had all of them. Then we started like building fireworks with it, just blowing them up and killing them. It was great. It was awesome. Yeah, we had like we had an airplane. I never got the giant aircraft carrier. Snake Eyes was cool. We had like the hydrofoil, the hydroplane boats. We had the hovercraft boats. We had tanks. We had, you know, it's like nowadays my kids all they want are Legos and Nerf guns. When I was their age, all I wanted were G.I. Joes and Transformers. The occasional ring RC car was always cool. Star Wars are awesome. When I was really